Photoplethysmography, PPG, is a simple and low-cost optical measurement method that is often used to detect blood volume changes in the microvascular bed of tissue. It is non-invasive and can be used to monitor heart rate, blood oxygen saturation, and other cardiovascular metrics.
1, 2, 1, 2.
The principle behind PPG is that blood absorbs light more than the surrounding tissue, so by shining a light source, usually LED, onto the skin and measuring the amount of light either transmitted or reflected, one can gauge the blood flow dynamics in the tissue. Here's how PPG typically works. Light emission, a light source, such as an LED, emits light that penetrates the skin. Absorption variation, the blood vessels absorb varying amounts of light during the pulses that correspond to heartbeats, which is affected by the blood volume changes in the microvascular bed. Detection, a photodetector measures the light that is not absorbed by the blood. This signal fluctuates in time with the cardiac.
Okay, let's just do a sound check quickly and we'll start in a sec. Don't have much time today, so we'll jump into development straight away. Okay, I don't have to monitor my own sound, my own voice. Don't like it anyway. Let's do this quickly. So I had that blog. Hopefully you read it. I did spend quite a bit of time making it, but yes, it was generally generated by GPT-4. Yeah, that image is not great. Let me know what you think of the layout and the general structure, the language. Yeah, I was tuning it down quite a bit. I don't remember how many prompts. Can probably check. And we're doing another one on PPG. Someone was asking what PPG is, so we'll have a whole blog on it. And yes, I'm more interested in all sorts of specific issues about the recordings themselves, so I don't care what it's actually called. We will actually have some practical examples, see what's what, the advantages, disadvantages of different recording types, mainly to do with transmitted versus reflected recordings. Yes, Googling helps quite a bit. Not sure what the bot will be able to generate in terms of images. Actually quite curious, but we might do this later. Yeah, I'm having all sorts of issues with my USB devices because my microphone is not properly connected via another pre-amplifier. Talking about amplifiers, sorry, I'm jumping around a lot, but we also have another blog on EEG hardware. Can open it at live server. That's not in production yet, but yeah, it's mainly to do thinking I want to record my own EEG. I've done it many times before, so should be more than capable to do that. But the problem is that my older gear, I can't use it anymore. I do have one of those old NI USB DAC, data acquisition device. Problem is I can't connect electrodes to it directly. I have to use a pre-amplifier, and Texas Instruments differential instrumentational amp could help a lot. And this is just some generic, yeah, don't need KiCad or anything like that. Don't know why it even mentions it. Yeah, we need a good CMMR. Don't know why the bias language there. A good common mode rejection ratio. Yes, you'll have to look it up. Or should I have a section in the... Let's... should we focus on this or move on? Let's move on to proper development. Add that to, yeah, it now looks better. That has now a background, so it looks more like an output. Yeah, we don't like ads, but hopefully they're not too intrusive. They're now delayed like by 10 seconds or so. I probably could delay them further. I was just playing around with the delay function, which is done on my server end. Yeah, this needs to be made clear that that filter order is only affecting the frequency domain. Should we do it now? There's a description, so the filter order selector, choose from 1 to 4, adjust the sharpness of the band filter. The default setting is at 2, and why do I have a feeling that's, oh, that looks correct. This thing would not actually show you the value, like the window size there. That little value there will actually change. This is in production, by the way, therefore the ads, we can go check it out. It's in this URL, pop it in the chat for you to play with. Can change your different types of wavelets, set the window size. Yeah, there's a lot to play with. So I might leave that there for now. We have another blog. Hopefully all these blogs will eventually turn into web applications, so they will be more useful than just text. They will actually show something useful, like e.g. signal quality. Yeah, we can do a lot. We can do a web application there. We'll see how we do it later. Yeah, this application is an earlier version, so a simpler version of the EEG data time and frequency domain. It's just scrolling through the file. You can select your channel, seconds, same as the previous tool. The newer tool, this one here obviously has also options to make the signal less noisy. You can play with that. Okay, the ads are really annoying. Should probably showing this on my what's called development server, not in production. So the ads not popping up. What else? Let's go to the bottom quickly. Jump around this one. Yeah, those 5 do not currently work. So should I go out of these 3? Any preferences for what I should be looking at first? Let's open them quickly side by side. Yeah, we had the original tool that used to work. We have some description to it that we can pop into ChatGPT. Might as well do it straight away. I'm pretty sure we had something already. Feature extraction. So this is feature extraction from images. I actually have some unique images that I could be trying this on. Frequency. Where is it? Feature extraction. Right, we don't have a description. That's that old LabVIEW, the HTML. It's actually whatever PHP. Yeah, I'm getting rid of them. And let's have an info text first. And this will just have that. We had the original video. It actually shows how it's supposed to work. But this text can be popped up in here. We have the description there.
Fast feature point detector detects corners in an image using the features from accelerated segment test, FASD, algorithm. Fast identifies all interesting features in an image and selects features so that they're consistently detected. Harris corner detector uses the Harris corner detector algorithm to detect corners. The Harris corner detector is a mathematical operator that finds corners in an image. Shi-Tamasi corner detector uses the Shi-Tamasi corner detector algorithm to detect corners. The Shi-Tamasi corner detector is based on the Harris corner detector, but there is a difference in the selection criteria of the corners. Shi-Tamasi works well in cases where the Harris corner detector fails.
Okay, so that's description enough. So essentially, should have detected type. So we have inputs. And detected type. Image as image options. Detected type should be fast Harris and Shi-Tamasi. Yeah, we have that description in the bottom. And we also need the raw data option. This will be on off, and the output, or should we just display the original image? No, let's just display the original image. So I have our outputs. Delete that. Original. Processed. Oh, come on. GitHub. Yes. And processed image. Right, and that's some description. So now the question is, should this be a Flask application or not? Or can it run on the client side? Yeah, we're happy with that. And let's start a new chat. Go in GPT-4 straight away. Yeah, I wish there was some sort of way to jump between in a more like Flask. Okay, let's see what it says.
The decision to implement a feature detection system as a Flask application or client-side JavaScript application depends on several factors, including the nature of the data you're working with, the complexity of processing, and the user experience you aim to provide. Here's a breakdown of considerations for both approaches.
Okay, many considerations: server size, processing, privacy, reusability and integration, development consideration. What's about that?
Development considerations. Python, used in Flask, has robust libraries for image processing like OpenCV, which can make the implementation of detectors like FAST, Harris, and Sheet-Mazi easier.
I think you just sold it to me. Yeah, on client side there might be limited capabilities. Let's go with Flask. Yeah, and we already have like what, 8, 9, 10 of them already, so it's just another one should be easier.
Creating a Flask application for feature detection in images is an excellent choice for several reasons, particularly due to Flask's ability to handle server-side processing and the ease of use of Python's image processing libraries such as OpenCV. Here's how you can structure your Flask application for feature detection.
I'm also checking what the images we could use as examples. Basic structure. So we have web interface, backend. The backend does get post requests using OpenCV to implement the feature detection. That's great. Saving the images temporarily. That's okay. Maybe change it later. Displaying the output, handling raw data. What? That actually is interesting. Normally when you're talking about biomedical images, you're thinking your, scans. But yes, actually, time series data can also be an image. So this actually could be quite an interesting thing to do, because we could just go into one of the other tools and generate quite a few images and see how the image detector deals with them. Deals with those. Or should we go imaging examples? Because the algorithm will be steps to implement feature detection, install Flask OpenCV Python headless. I have Flask install. Yeah, Ajax. Did use Ajax in one of the applications, but not in a more recent one. It shouldn't matter too much. So EG versus say micro CT scans. Just see what it says. Yeah, obviously you will process the image quite differently, because and you probably look at different features. Purpose of use, microST, data characteristics, volumetric, image processing, complexity of data. Yes, the data is more complex. I mean, I don't think I have 3D images anyway. That would be Probably could try and get some 3D micro city, but at first stage it's probably just gonna be 2D images. Yeah, and what's the final outcome? Is that just using it for example at the moment, but the diagnostics, what clinical setting, research, development, engineering context. This will dictate the precision speed. We have one like many for educational purposes at the moment. So speed is important. Optimize for speed. Now, yeah, where do we get the images from is important. Have another folder called data. Index HTML. Let's do the structure of the Flask application files and folders. You don't need to spell correctly, ChatGPT will understand. Base layer, main page, result display. Okay, so not in a single page. A single page panel, please. For single page panel, your application, static JS images. That's all the root definitions. It's a bit odd. Can I have a standard? What was the last application that we have made? This one. Let's do it in the same way. IG spectrum, Shandy noise. IG spectrum, Shandy noise. Yeah, this one here. Yeah, I like this structure. And this will be the images. And we'll see where we get the images from in a second. Right, so the app is called feature extraction. It will have an app by requirements readme static style. This one, what's the standard name for main JavaScript? Templates index HTML. Now data, this will be images. the JavaScript is not for EG. And this will be image of 1. And let's do this. Okay, I don't know why I just rearranged the thing. Explaining each file. I didn't ask you to. That's okay. Can we stop generating that? Okay. I have those. Those go next. Generate all necessary code for the updated HTML4. Well, just HTML. I mean, this is the first time I'm generating HTML, so by the way, I have an upload. Okay. Yeah, I'm just generating the templates for the files. The JavaScript file. While it's generating, let's do the folders quickly. Or should we just copy them? Well, this definitely goes into a folder called Ava, because we don't actually need this. We have the info file. Let's copy those quickly. My app requirements. We will need to regenerate those, obviously. Can delete that. Trash. It's JavaScript. Yeah, we're using the DOM content loaded. That looks good. A py file. Can straight away correct this. Into the new application name. Generated some Python code. Just the template. Right, we already generated the HTML. Yes, we want to separate CSS, and probably after CSS we'll have to update the HTML again. So we might pop. Obviously, we're not ready to deploy with. We just started literally with this application. We don't have much time. Okay, where's the CSS? The CSS. Yes, all the body H1, H2 should be commented out because we might actually leave it for now. Where's HTML? Right, HTML template. Yeah, just checking that it doesn't have any styling or JavaScript in it, because we would like all those to be separate. It's a bit messy. It's a bit messy. Viewport title. It's obviously we need to change the title. Okay, I don't like this already because I said the style CSS is not in CSS folder. It's actually in the static folder, whatever. Well, yeah. Content ID, form, input, file, image. And we're using Plotly JavaScript main. I do this. the local server quickly. Choose file, extract features. What? It's a bit odd. I don't think this description is wrong. A feature extraction from images. This can go there. And all this description can go for now. A format document. Let's see what's what. Because we have okay. HTML, a JavaScript. Let's go for JavaScript. A JavaScript can be renamed main JavaScript. Can get rid of all that. Extraction. Explanation. Need some images and data, or at least one. If we are doing EEG a segment, we could actually I don't know why this slider is not great. This is an actual seizure. How about we do that as an image instead, and I can export image, download plot as PNG, done. And let's pop this let's call it seizure 1 PNG, pop it into data, right? It should be a file. Should just get rid of all the labels maybe later. We need copy relative file info. Okay, more prompts. Example image to use is in We haven't done Python yet. So we're using Flask. Secure file and what? Just go with it for now. Check structure. Colors. Yeah, we'll leave the colors for now. Okay, example, the image is in this file. Okay, in HTML. Where do we edit? See what it looks like again. Yeah, choose file. Definitely. Okay. And the files are all the image files are in this folder. Choose first file by default. So this actually does not matter. Just pop another image in there. What can we use? We actually had this images for the wavelet image compression, so we could use some of those. Could use some of those images. Sorry for the ads. Which one's good? Yeah, the first one. Image compressed wavelet. Compressed wavelet. Static images. Right, so this should be in static images. First one, MRI brain. Say O2, yes, say this one. Static images. Okay, let's rename this into images and put it in the static folder. Name this one one seizure. Yeah, so it's just on top of the file. a copy path. It's meant to be relative path. Static images seizure 1 or 1 seizure, whatever it's called. All the image files are in a static images folder. Choose for first file by default. Can get rid of that. Add a drop down menu to select the image file. Yes, for the tecta type, we want to do that. Yeah, that's GitHub Copilot. And those are good. Why are we using web browsing? Should be just using the standard GPT-4 default. Filter out files that are not images if necessary. Yeah, we don't really have to do it. Well, not at this stage. Change our HTML. Style. Render template. Yeah, we don't need that secure file import because the images will be just on the server. Get rid of that image folder. That's right. Load for no, we don't need to do that. Okay, extract feature file path. That's not a bad suggestion. Yeah, we don't want a dummy extraction function, we want a real extraction function. Okay. Yeah, let's update this Python code. HTML. Next. Doesn't mean we don't need Plotly. Deep Plotly chart. Format document. Just clean it up. Right, so we have the file. Choose an image, choose detector. And why is that not populated? Why is it something that is flicking? Make sure image names are popular. Yeah, let's do. How do we do that? Question is that if it's rewriting the whole Flask app or just the bit. Take the type. Debugging is true. Yeah, I'm still debugging. If you have snippet list here, let's create an index HTML template for the dropdown. So HTML. Scripts. Yeah, we don't have much time. Get something running quickly. Data. Drop down menu. That's the same image. Yep. Yeah. Option. So why? Is this the same? I don't get it. Why is this not populated? Images, static images. and in index.html, I'm going in circles here. This is just the same. Don't get it. All right, I know what's the problem is, because I'm not running it as a Flask application. I have to run it as Flask. That helps, doesn't it? File not found, static images. Static images. Static images. How come the file is not found? Copy, search. And the folder, copy relative file, example, I get. Can you quickly fix this for me so we can actually move on to the actual development? Is the whole thing? Are you suggesting me to replace? Right. Okay, now it's working. Okay, we are in business. Make sure images are displayed. No, I'm using Copilot all the time. It's just I actually had to change its settings as well. Copilot. No, I'm using it all the time. I didn't realize it had quite a few settings that I think it was actually set up for developers where you doing everything myself. I'm not a developer, so now it actually should be better. I haven't checked it yet. Make sure images displayed in the HTML files. So I can try them both side by side. I would actually love to ditch ChatGPT. Well, because it's more expensive. I don't really need it. If I knew how to use GitHub Copilot properly. So for example, yeah, I'll try them both. So say, obviously, it's directing us to change the HTML because we're meant to have these two images, original and processed. So we have the drop-down menu right here. In a place original and process images side by side. Yeah, that was yeah, now it's thinking and it generated the whole code, giving me two options. Yeah, like the second one, accept for tab, save. Didn't I say side by side? Definitely not side by side. Original image, and well, okay, let's see. Script HTML, make sure the images are displayed in the HTML file. First image. Yeah, so this is a much better example. Can place it together. Oops. Right. So yeah, you can tell GPT-3 is actually having context for the whole thing. I'm surprised. GitHub Copilot, assuming it has access to all my files and everything. It's literally in the development suite, but when it's giving me advice, it's giving me generic stuff, whereas ChatGPT gave me the actual file with the right folder and it actually works. So yeah, I'm not sure about tried to use one of the available for students with my university email after, so it was a bit disappointing. It's still using 3.5. The thing with 3.5 is yeah, I think it's a problem that people use it and then they go get disappointed from it. The main reason I'm able to use and I don't know why it's in web browsing, is the fact I can start fresh for now and do it quickly because I'm running out of time. But if I'm in default GPT-4, the main reason I'm able to use it is because it can store the whole context for all the files. So if I have all this 1, 2, 3, 4, 5, 6 files, if I pop each one of them, info, I'll go info last. The order is important. Index HTML first. So if I start from scratch, the good thing about it, is it the right file? Yeah, and I'm just telling it to read the code and don't generate anything else, and that's because it then stores everything in its memory somehow. Can use this line seem to work quite well at the end. Pop this again. So it's actually, yeah, it says yeah, great, the course provided question. So it has it in memory. It read the Flask application and that's great. Style says I can sort it out later as well. JavaScript is most important and we use the same line confirm you read it and do not generate anything, any code or anything else. Copy all. Yeah, so GPT-4 is able to keep the context of all the different files. So we're talking, what are we talking, 100 lines in HTML, 30 lines in Flask so far, 40 in JavaScript. And now I can actually ask it questions. I'll go into my application. Yes, that HTML that GitHub Copilot generated didn't actually work. Now I'm actually trying to find it and get rid of it. This one here, it gave me very generic stuff, and yeah, I just don't know how to use it. The whole point for me is that I'm able to where was I? Oh yeah, read the JavaScript. It gave me some error or something. Let's read this quickly.
I have read the JavaScript code you provided. It sets up a client-side script to handle a form submission by sending the form data asynchronously to a server endpoint, upload, using fetch. The server is expected to respond with JSON data that either contains chart data for Plotly if the feature extraction is successful, or an error message if it fails. Upon receiving a successful response, it calls render Plotly chart to create a chart using Plotly.js.
I wasn't actually listening to what it said. So generating another prompt. You don't have to worry about spelling. Just pop it in as is. And it's giving me, yeah, it has the context. So that's the stuff that I already have. And then it's telling me what I need to change. And it looks correct. I don't have the processed image yet. Hopefully we'll have it soon enough. Just pop this in. Save. Yeah, I don't have the processed image. That's a problem. And it can do processing for me because it had the Python code as well. Display. Sorry, we're in the wrong. Okay, I'll continue this later. See you in a bit.